Okay, welcome back. We're on page 293 talking about returning a value from a method. Now, we've been doing this since like the second week of class, right? I mean, we've been doing things like int age is equal to integer parse int 12, right? We've been doing that. So this is, again, this is really nothing new other than the fact that instead of using a store-bought thing that returns a value, we're creating our own thing that returns value. Say, is it against the rules to have a method that returns a value and then just ignore it? I mean, clearly, typically you would say, please, Mr. Method, may I have an integer? And you wait for the thing and you take the integer from it, right? That's normal. But is it legal for you to say, please give me an integer, and then you turn your back and walk away? Is that legal? In other words, let's do that here. I want to say integer parse, only if I spell it right, parse int 1, 2, 3, 4, 5. Okay? Is that going to cause a problem? No, it's not. It's perfectly legal. It may not, okay, it may not make any sense, but it is perfectly legal to ask for something and ignore it. Let me give an example where that might come up when you're reading a file. Let's say you know that the first 3 lines of a file are like a header or comments or something, and you don't really care about them. So remember we talked about the scanner guy. We had, you know, next, right? Next line. I can just do next line, next line, next line, just to throw, you know, basically just ignore the output and then start reading and storing the output, because the first 3 lines I don't care about, right? So it's perfectly legal to call a method that returns a value and just don't do anything with it. Don't even look at it. Okay. So let's talk about the rules for the return statement. Okay. So the return statement is going to have to be the last statement in the method, and I don't necessarily mean last physically. It's the last statement. Let me give you an example of what I'm talking about. So if I go down here and add something else to this, I say, you know, system.out.println. This is silly. The machine's going to come back and say, wait a minute. And it says unreachable statement, which means nothing happens past the return. So 99% of the time, it's going to be the very last item in the method. Now, there are some exceptions. For example, up here, let's say I'm doing some input validation of some sort, right? I could just say, you know, if num is equal to 0, then return. Now, this is legal because there's nothing that appears beyond the execution of line 72. I mean, this physically is there, right? But that's not what we're talking about. So I answered 2 questions. One is the return has to be the last logical statement in the thing because nothing can appear past it. And can you have a return statement when you don't have anything that you're returning? And the answer is yes. You just use the return keyword, but with no variable or no constant that shows up afterwards. So here I have to return an answer. Here I just have to do a plain old return. Okay, and we're actually going to use this technique coming up soon to do all sorts of input validation. Like, is it less than the acceptable value? Return. Is it greater than acceptable value? Return. Oh, okay, now you're good. Now let's go ahead and calculate the correct answer and return the correct answer. Cool? Okay. So, it's almost always best practices to put it at the end. And there's a way you can code things to make it happen that way. Using this little technique, like where you assign a variable and then the last. In fact, when I create methods that return something, I almost always start like this. Okay. So if I say, you know, public static, you know, I don't know, let's do string. And then, I don't know, whatever it is, whatever. Okay? When I do that, I almost always just start with Dang it. A beginning value, and then turn right around and do a return. And then after I got those two pieces in, then I can go in here in the guts and start actually building it. Okay? I'm just saying that's the way I do it, because I have to always start with a value, and then I always have to return a value, and everything else goes in the middle. Okay, and this makes, see, look what happened if I didn't have that. Dang it. I'm going to get a red squiggly saying, hey man, this thing doesn't return something. So while you're writing it, I don't like red squigglies while I'm writing the dang method. I mean, one way to be, look, don't bother me, I haven't finished yet. Right? That'd be one way of dealing with it. The other way is just do it this way. Go ahead and put the starting value and put the return value, and that way it won't complain to you at all. Okay. So on page 300, they talk about returning a Boolean value. Okay. How is that any different than what we've been doing? I have no earthly idea. So moving on. Returning a reference to an object. Okay. Let's do something. Let's do another, we'll do another whatever. Actually, yeah, okay. Public static. I have no idea. I'm kind of running out of things. Let's just do kumquat string val. Whoop! I didn't tell it void. Okay, and then I want to do something to this guy. God only knows what. So up here. Well, actually, I didn't actually have to do that. I could have just used display given message. So I go here and say, so string wombat is equal to hello. And then I'm going to use that one we called the display given value. Not given value, given message. Ooh, I already have wombat. Okay, we'll call it junk. I'm running out of variables, aren't I? Okay, so again, this is not complicated, right? Junk is an instance of a class. It's an object. It's an instance of the string class. Remember we talked about the string class is not one of the primitive data types. It's actually a class. Okay, so okay. I mean, whoopee! I can't imagine why they spent a couple of pages talking about returning a Boolean value or returning a reference to an object. Like, dude, okay, whatever. On page 302, there's a philosophical section, and you probably should read this. It's good stuff. I'm not going to read it for you. But it goes over the philosophy of like, why are we doing all this? And so the functional dependency is the technique of breaking large project into chunks. We also use the word encapsulation to talk about this. But encapsulation takes the idea of functional decomposition one step further and bundles things together that belong together. But just breaking them apart is just called functional decomposition. So I've got 10 things I want to do. I could put all 10 in my main method. That would be one way of doing it. Or I could put the first 2 in another method, and then the next 3 in another method, and then the next 1 in another method. Yeah, I break them up into chunks that make sense to me. So if you have a long process, let's say you're ordering from an e-retailer. So one of the things is going to be, logging in. Well, that ought to be a method, right? And then selecting items to purchase. That ought to probably be a method. And then reviewing your shopping cart. Yeah, that ought to be a method. And then collecting your payment. That ought to be a separate method. In other words, don't put all that in one gargantuan thing because they're separate things. Logging in is separate. Viewing the catalog of items and picking out things you want, that's separate. And, processing your payment and all that. Those are separate kind of things. So it kind of makes sense to break them up and put them into methods. Okay. So, having said that, one more time, why are we doing this? Okay. So, again, kind of sort of pay attention. This is important. It's easier to concentrate on a small thing than a big thing. If I'm building an e-commerce website, my head's about to explode because I'm trying to keep all this stuff in my head at once, and it's just way, way too much, and my head is just not that big. But if you said, okay, I want you to write this chunk of the code that allows the user to gather things from the catalog and put them into a shopping cart. Okay, I could probably keep that in my head. So the idea is to break it into small pieces so I can concentrate. It also makes it easier to program because I don't have to think about side effects of what I'm doing with somebody else. It makes it easier to debug. When things go wrong with the shopping cart, I know it has nothing to do with login or nothing to do with payment processing, right? I can take those things out of my mind and just debug the things that I know. In other words, it makes it easy for me to zero in on what's wrong. So it's easy to code and it's easy to debug, okay? And then the third one is, if you're in a commercial scenario, you're probably not working alone. You're probably working with a team of programmers. So I give Sue the chunk for logging in. I give Dave the chunk for perusing the catalog and building the shopping cart. I give Bill the chunk for reviewing the shopping cart, and I give Sally the one for processing the payment kind of thing, right? So if I'm a manager of a software team, I really like this functional decomposition / encapsulation thing because I can hire 4 people to work on the same project. Kind of makes sense, right? Okay, good. And then the fourth one is I can reduce the amount of duplicated code in my application. So why is that a big deal? I mean, why do I care if there's a lot of duplicated code? Well, first of all, it makes the program physically smaller. That would be kind of cool. And the other one is, let's say, for example, inside your application, you had it calculating the state tax in 18 different locations, okay? And then they changed the tax rules on you. So you have to go in and find every single place where you calculated the tax and tweak it. That would be rather annoying. On the other hand, if you had put the calculate tax into a method and in 18 locations all you did was call that method, I would have to go to that one location in the entire e-commerce website and make one change one time, and then everyone else gets to see the changes. Okay, that's good. All right, so of those things, making it easier to think and program, making it easier to think and debug, making it easier to have multiple programmers, and making it easy to not have duplicate code. Which one of those do you think that the manager is going to be the most impressed with? I mean, sure, the manager cares about software quality and duplication, but they're really concerned with how fast I can get this new website up and running, kind of a thing. So they're very interested in this functional decomposition / encapsulation from the basis of if I want to speed the development of the website, I just add more people to the team, and that's what they're interested in most of the time. Okay, coming up in just a minute or two, we're going to do an example of using input validation and the reason why you don't want to have a lot of code reuse. But as always, we're coming up on the 15-minute mark, so we'll do that in just a second.